Now, as the book chapter says, periodic table, periodic properties. What is the periodic properties? See, we can see that the properties of all these elements repeats after some interval of time. See, after some elements gets over, once again the same property repeats. So that is the periodic table, periodic property. There are certain properties which will be repeatedly repeats after regular interval in the modern periodic table. As we can see here, lithium and sodium, see, atomic number is 3 and 11 are 19 here, but number of valence electrons remains same here, and they are all alkali metals. When we are putting in this order, after some time their property repeats. So that is a periodic table property or a periodic property which repeats after some interval. We are going to learn them or understand them why it is like so. Is it okay? Periodic property. Then here, what any idea what is the modern periodic class states? Any idea what is the modern periodic class states?
Uh, s- sir, is it like that?
Yeah.
Okay, I don't know, sir. I don't know.
See, why we arranged all these things is here some physical and chemical properties. Okay, physical and chemical properties of an element in a periodic is a periodic function of the atomic number. See, physical properties and chemical properties, all of these elements, whatever is arranged over here, they are depending on their atomic number. Since atomic number is 1 over here, all for them, they are all alkali metals. They have two electrons outermost orbit. They are all alkaline earth metals. They are all non-metals. They are inert gases. So the properties varies depending on both physical and chemical properties, depending on their atomic number. That is the reason we have arranged them in atomic number order, and that is the modern periodic class states. Physical and chemical properties of an atoms depends on the number of electrons in the outermost orbit, or it's the periodic properties of their atomic number. Now we will go to study some of the basic properties in this chapter, not all. Some of the basic properties we will go to study. So, first of all, now we know what is the period number, right? How many periods are there in my table? Modern period table. How many periods are there?
The seven, sir.
7 periods are there. Horizontal rows are known as periods. So, in the first period, how many shells are there? In the first period, how many shells are there?
So once,
One, right? In the second period,
so two.
two. Third period, three. Fourth period, four. Fifth period, five. See, number of periods is equal to number of shells, right? Number of periods is equal to number of shells. Then that is about the main properties. Periods. 7 periods are in my table, and elements with the particular period has so many shells in it. So many shells in it. Then how many groups are there? There are 18 groups. 1 up to 18 here. There are 18 groups. What is the specialty of each group? What is the specialty of each group?
So the valence electrons will be the same, sir.
Yes, number of electrons in the outermost shell, that is valence electrons, are same in a particular group. Group 1 means 1 electron in the outermost shell. Group 5, 15 means minus 10 you do it. There are 5 electrons in the outermost shell. So like this group 18, subtract 10, there are 8 electrons in the outermost shell. So they are periodic properties of their atomic number. Is it okay? So as we go down, what is happening? Number of shell is increasing by 1, right? As we go down the group, number of shells are increasing because period number is changing. As we move from left to right, number of shells remain same, right? Number of shells remain same, but number of valence electrons will increase each time by 1. The periodic property. By 1 they increase. Either row wise we go, number of shells will increase by 1. If you go from left to right, then number of electrons in the valence shell will increase by 1 each time. So the periodic properties of the elements because we arrange them according to their atomic number. Now, we had to learn some basic things about all of them. Before that, let us see what and all we learned till now. See, modern period table, horizontal rows are called periods, vertical columns are called groups, right? These are nodes. Horizontal rows are known as period, vertical columns are known as groups. You know it. Then properties of an element, like we're going to learn them. Atomic radii, that I'll teach you tomorrow. Atomic radii, metallic character, non-metallic character, electron affinity, electron negativity, ionization potential. These are the properties we learn tomorrow. That is there for our 10th standard board exam. Vary across a period. These properties will vary across a period and down a group. These properties will change across a period as well as down the group. So they are known as periodic properties. All these properties we will discuss tomorrow. The periodic properties. Then elements in which outermost shell is incomplete are called normal elements. Incomplete, except the last column, last group, that is 18th group. Others are known as normal element, that is 1A to 7A. 1A to 7A, we are called as normal elements because they have only one incomplete shell. That is, I'll explain S and P block later. 1A, 2A, 3A, 4A, 5A, 6A, 7A. You can see here now 1A, 2A, 3A. Here you have to come, not in between. 1A, 2A, 3A, 4A, 5A, 6A, 7A. They, here 1A, 2A, they are known as S, they have S shell. These have P shell. I'll explain what is S shell and P shell later. So they are known as S block elements or P block elements. 1A, 2A for S block, 3, 4, 5, 6, 7A for P block elements. They are known as normal elements. Whereas 1B, 2B, 3B up to 7B and 8, they are known as D block elements or transition elements. In between whatever we have seen, 1B to 7B, 1B to 7B, and this 8 in between here 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8. See, these are known as transition elements or D block elements. May not be required but know in basics, which already I learned in 9th standard. Then elements in which last three shells are incomplete. Last three shells, they are known as inner transition. Here two shells are incomplete, they are D block elements. Inner transition, if there are three shells are incomplete, that is F block elements. They are lanthanides and actinides, they have been kept at the bottom. This below lanthanide actinides are there now. They have three incomplete shells, they are known as F block elements. Three shells, last three shells are incomplete. Here two shells are incomplete. Here only one shell is incomplete, normal. Transition, inner transition. Is the words are fine? Normal, transition, inner transition. What we observed till now, in a group, priorities are same, features are same. In a row, number of shells are same. So what happens? Diagonally, they show some similarities. Diagonally, for example, if I move like here, diagonally if I move, they show some similar properties diagonally, because as we go down it's the same properties, as we move right they are same priority properties. So diagonally combination of both will come over here. Diagonally they have some same properties, that is known as the diagonal relationships. The similarity in properties between certain elements of different period placed diagonally to one another, placed diagonal to one another in a period table is called diagonal relationships. That also is required for us. Diagonally, they have some common properties. Our features will vary. The diagonal relationships. Normal, transition, inner transition, diagonal relationship. You can take the snap of the screen and you can make a note of it later in your notebook. Then comes alkali metals. As I told you before, 1A group, that's the first group, are called alkali metals because they form strong alkalis with water. We'll see what is alkali in acid, base, and salt chapter. They strong alkalis with water. Whereas second group elements are known alkali earth metals, which are water insoluble. They are weak alkalis and their oxides are alkaline in nature. Remember, I'll teach you later. Alkaline nature and exist in the earth. You'll see what it is. Alkaline metal and alkaline earth metal. Group 1 and group 2. Then right side when you go, halogens. 7A has salt forming tendency. Chlorine, fluorine, bromine, iodine. They have salt forming tendency. They are known as halogen, means salt formation. Then NaCl, sodium chloride, the salt what we are eating, it has a salt forming properties. So they are known as halogens. Halogens are salt forming properties are there. Fluorine, chlorine, they they come in here. They are halogens here. This entire group, 17 group. Then noble gases. Elements in the zero group are called noble gases because they are hardly react with any element due to its stable configuration. They are stable in their architecture, so they don't want to react with anyone. So they are known as noble gases, inert gases. This is the very, very basic things you have to remember.